All right, hi Year 11s, this is Mr. Lim here again, and this is another special request about variable volume containers. Okay, so variable volume containers are your typical balloons and stuff, where their volume can change depending on the various changes in conditions. Now, the thing that you need to remember about variable volume containers is that what's holding them in is effectively the air pressure from the outside, which is effectively the collisions from the outside holding and equaling the collisions on the inside. Okay, so something that you need to know about variable volume containers is that the pressure externally must equal the pressure internally. Okay, so you can have, changes to the external or internal pressure. We're just going to deal with changes to the internal pressure for now. All right, but the idea is that you can also change the external pressure, and that will change the way that your volume goes. All right, so the idea is that you need to be able to identify what happens if you change the temperature or if you change the amount of particles within it, right? Or even if you change the external pressure. But the idea is that because you have these particles inside there bouncing off the walls of the container, right? Any changes to those particles are going to change the size of the balloon, okay? So that balloon can get bigger and smaller. So the idea is that if you have a higher temperature, okay, what does that lead to? It leads to the particles moving faster. Their speed increases, okay? Particle speed increases. All right, if their particle speed increases, they collide more often with the walls. Which increases their pressure, which leads to increase in pressure. Now, you can't have the internal pressure higher than the external pressure. So you've got to make sure that the pressure internally and the pressure externally are equal. So because your pressure increases, that effectively means that the balloon skin is forced outwards. When it's forced outwards, what that does is that it lowers the amount of collisions internally. Why will that occur? Okay, so let's have a think. If I have this balloon, if I increase its size, it's going to take longer for particles to reach the other side. All right, and if it takes longer for the particles to reach the other side, they're going to collide with the walls less often. Okay, so you've forced it outwards, and then you're going to have lower collisions internally. If you have lower collisions internally, that means it's going to bring the pressure down. Okay, this brings the pressure down until it becomes equal with the external pressure again. All right, so that's the idea of temperature and the balloon size. So temperature and balloon size, or the volume, are proportional. Okay, because the idea is that the internal and the external pressure have to be maintained as the same. All right, so this here is just the explanation for temperature, but it should be enough to understand that you've got to discuss what happens to the particles and what happens to the pressure due to the collisions, okay? What happens then to the balloon skin, and then how does that bring the pressure back to be equal, okay? So if you are wondering what the other relationships are, the other relationships will be the number of moles will be proportional to the volume. So if you increase the number of moles, you'll increase the volume, okay, because you're going to have more collisions with the walls because you've got more particles, which means the pressure will increase, which means the balloon skin is forced outward again, and then it lowers the collisions internally, which will reduce the pressure, which will bring it back to equal, okay? And if you have a change in the external pressure, right, the external pressure and volume, if you increase the external pressure, you will decrease the volume, so it's a inversely proportional relationship, right? So the relationship between temperature, the number of moles, and the external pressure in variable volumes containers can be expressed as those three things. Why don't I just rewrite that? Temperature 1. Temperature and volume are proportional. Okay, so those are the three relationships that you need to know, but you need to know that you need to discuss it in terms of these things here, how they collide with the walls, and then how that changes the amount of collisions and therefore the pressure readjusts itself. All right, and that's it for variable volume containers. Adios.